Good morning, my dear students. In this video, we will delve into the fascinating topic of linear equation, two variables. This is chapter 3, class 10th mathematics. But before we begin, let's take a moment to recapitulate the previous chapter, our real numbers and polynomials. It is essential to have a solid foundation in these topics as they serve as a building blocks for our understanding of linear equation. So we should recap the previous chapter, real number, which is chapter 1. Here we have studied here we have studied composite number. Every composite number can be expressed as a product of primes. This theorem is incredibly useful in proving various theorems, formulas, and expressions. Then we have studied prime number, numbers that are only divisible by 1 and themselves. Number which is not prime number is defined as a composite number. Then we have studied rational and irrational numbers. Rational numbers can be expressed as a form of p by q, and irrational number we cannot express it as a form of p by q. We cannot express it in the fractions. Okay, such that root 2, root 3, root 5, root 15, and pi. We have explored many proofs, root 2, root 5, 3 plus 2 root 5, and so on. Then we have defined divisibility theorem. If p divides a square, then it will divide a as well. Then we have studied chapter 2, polynomials, where we have studied sum of zeros, alpha plus beta equal to minus b by a, and alpha into beta product of zeros c by a, for the equation ax square bx plus c equal to 0, where a not equal to 0. Then we have explored the relationship between the coefficient of polynomial and its zeros. Okay, this was the recap, and in this video we will focus on two methods. One is graphical method, second is algebraic method. And these methods have a real life application, making them highly relevant and relatable. Let's consider a practical scenario. Suppose that there are two brothers. There are two brothers. This is brother 1, this is brother 2. One buys one biscuit daily. One biscuit daily. And other buys two biscuits daily. We can represent this situation as an equation, and this session will help us to understand the basic concepts of this chapter. Okay, this is very helpful, and we want to connect this chapter with famous mathematician Aryabhatta, Ramanujam. Did you know that the ancient mathematician and astronomer Aryabhatta, who lived in the 5th century, who lived in the 5th century, Aryabhatta, Aryabhatta, 5th century AD, made a significant contribution in the field of algebra. Aryabhatta not only introduced concept of zero, we know zero is defined by Aryabhatta, and the decimal system 0 up to 9 is defined by Aryabhatta. But he also developed method to solve linear equation into variables. His work laid the foundation for the advanced algebraic techniques that we use today. So when we study linear equation in two variables, we are following in the footsteps of the brilliant mathematician from our own Indian heritage. And we should not forget the contribution of Ramanujam. We should not forget because he is renowned for his extraordinary contribution to the mathematics, who explored the fascinating properties of quadratic equation, paved the way for few insights and discoveries in mathematics. His brilliance and passion for solving mathematical problems continue to inspire generation of mathematics around the world as we delve into linear equation into variables. We can appreciate the rich mathematical heritage of India and remarkable contribution made by Indian mathematician Ramanujam Aryabhatta. Salute you, sir. Then let's start to understand the chapter third, which is pair of linear equation into variables. Here, Akhila went to a fair in her village and she wanted to enjoy rides on giant wheel and play hoopla, a game in which you throw a ring on it items kept in a stall, and if the rings if the rings covers any object completely, you get it. The number of times she played the hoopla is a help. The number of rides she had and giant wheel. If each ride cost 3 and game of hoopla cost 4, how would you find out the number of rides she had and how many times she played hoopla provided she spent 20 rupees? Here we have denoted these story in the form of some expressions. This is a two equation of two variables. Here y equal to 1 by 2x, because the number of times she played hoopla by y. 3 rupees and 4 rupees. Total 20 rupees. Clear? Now, A pair of linear equation in two variables can be represented and solved by graphical method and algebraic method. That was my objective. Now, algebraic method can be classified in substitution method, elimination method, and Cramer's rule, matrix method. It is also known, but in class 10th we will study only on this method. Clear? And this method, graphical method. What is graphical method? A pair of linear equation which has no solution called an inconsistent pair of linear equation. Equation may be consistent pair of linear equation. Equation can have many solutions. Equation may be dependent of linear equations. Without graph, we cannot study the graphical method on the same coordinate plane. The point intersection between two graphs. Suppose that this is the line cut one point. This is the point of intersection. Line may be parallel. Line may be parallel, never intersect each other. It indicates no solution. It indicates a unique solution. If the lines overlap, if the lines overlap L1 and L2, then it indicates many solutions. Okay. What is inconsistent pair of linear equation? Inconsistent means no solution. That given equation which does not provide any solution, we can say that is inconsistent. We can say that equation is defined as inconsistent because it has no solutions. Here, given equation 1 and equation 2, these are the pair of equation, but it has no solution because it is parallel. Here 2x, 3x. We can write the same equation 4x, 6y, 10. Second equation 4x plus 6y equal to 8. Both coefficient is same. Both coefficient are same. Here constant term is different, then this equation defined as a parallel lines. Okay, right. So these type equation, if coefficient is the same and constant term is different, these pair equation has no solution because the second equation is a multiple of first equation. These lines represented by these equation are parallel and will never intersect. Will never intersect in future. There is another example, x plus 2y minus 4 and 2x plus 4y minus 12. If we multiply 2, we get the same parallel lines. 2x plus 4y minus 8 equal to 0. Constant term is different, otherwise other coefficient are same. So we can say that this is an inconsistent pair of linear equation. Inconsistent means which has no solution. If their equation which has no solution is defined as a parallel lines, because it will never intersect in future. Right? Are you getting it? In next video, next slide, these are the consistent equations. Consistent equation which has a solution, which has a solution. Consistent term consistent defined as has a solution. That means equation there has solution is defined as a consistent equations. We can classify this point in two ways: consistent pair of linear equation and dependent pair of linear equation according to philosophy. Consistent pair of linear equations and dependent pair of linear equation. Here, consistent pair of linear equations, suppose there are two equations. First one is 3x plus 2y equal to 7. Second one is 2x minus y equal to 4. Consistent pair of linear equation claims that if there are equations, then these equations should have unique solutions because it intersect each other. If this is equation 1, then this is equation 2, it will intersect each other. This is a intersection point of equation and equation 2. We can find one unique value which satisfy the both equations. Here x equal to 2 and y equal to 1 is the solution, 2 comma 1. If we put these value, we can get the result, and it will be the same left hand side and from right hand side. Put the value, 3 2 is 6 and 2 1 is 2, 6. Here 3 and y, here x should be 1, here x should be 1, this is a misprint, and y should be 2. 3 2 is 6, 2 2 is 4, then we can get 7. Clear? Now this is another example. Here both equation can intersect each other. So these lines intersect because it is consistent, it has unique solution. Consistents have a solution only. It may be unique, it may be many. Clear? Dependent pair of linear equation. That means one equation is dependent from other. The pair of equation is dependent because the second equation is multiple of the first equations. That means it coincides. Here we written same equations because if we multiply in first, we can get second. Here we will multiply with 2, we can get second equation. 2 2 is 4, 2 3 is 6, 2 8 is 16. So we can say that the pair of equation is dependent because the second equation is the multiple of the first equation. Both equations represent the same line, so they have infinitely many solutions. Here there another example: 2x plus 3y minus 9, 4x plus 6y minus 18. If we multiply 1, we can get the So we can say these lines just overlap each other. This is line 1 we have drawn. Again we have drawn second line. These type of diagram is defined as coincide. Clear? Now, in previous slide we have stated two types of equations. First one is a1x plus b1y plus c1, where x and y as a variable, a1 b1 is the coefficient of xy, a2 b2 is the coefficient of xy, and c1 and c2 is a constant, taken as a constant terms. Now if we fixed these equation in our mind, then we can solve easily any equation, and we can define the nature of the equation. So we here we summarized the previous slides. These two equations defined as a parallel lines because it has no solutions. Exactly one solution, many solutions. Clear? So the equation, the parallel lines, pair of linear equations which is defined as a parallel lines, if it is a parallel lines, then it will have no solutions. If these lines intersect each other, it will have a unique solutions because there will be intersection of point. But if these lines coincide, then it will touch each and every point of both equations of, then we can get many solutions. Here no, here one, here many. Clear? Now if these equations are given, we can compare with the ratio. If the ratio of the coefficient of the given variable are same and their constant are different, then we can say that these are the parallel lines. If given coefficient of and their ratio is not same, then we can say that these lines will intersect each other, and exactly these have only one solutions, which is defined as unique solutions. Now if these coefficient and constant term taken as same, because it will overlap each other, so it will coincide each other, so we can say that these lines defined as coincident lines, it will have many solutions. If these condition of compare of ratio is followed, we can get the nature of these lines. First, if they are a coefficient are same, then we can define as a parallel lines. If they are not same, we can define as a intersect line. If coefficient and in constant term are same, then we can define these lines are taken as coincident lines. Clear? Now we should solve the first exercise as we have promised. Okay. Now we should recap the formulas in the mind. A1 upon A2 and B1 upon B2. A1 upon A2 and B1 upon B2 and C1 upon C2. If we have learned these, then we can get all solution of the exercise in easiest way. Now, question 1. From the pair of linear equation in following problem, find their solution graphic. 10 students of class 10th 10 students of class 10th took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. So, what will be the solution? So, we suppose number of girls, let number of girls are x, number of boys y. Clear? Total number of students are given. Total number of students given 10. Then we can say that x plus y, therefore we can say that x plus y equal to 10. This is the first equation of given problem. Now, according to the questions, number of girls is 4 more than number of boys. According to questions, number of girls is taken as x. Clear? Number of girls is means equal to more than the number of boys is 4 and more than the number of boys. So we can write this equation x minus y equal to 4. This is the second equation. We have optioned both equations. Now, to represent this equation graphically, because we will find the solution of the given problem graphically, it is mandatory. So, we should draw a graph. Before drawing a graph, we should have information about the point, because if we have no information about the point, then we can not draw the graph. So, first we should find out the point with the help of equation 1. Here x and here y. If we take y as a 5, then x will be 10 minus 5, here will be 5. If we take y equal to 6, then 10 minus 6 will be 4, value of x. If we take y equal to 0, x will be 10. If we take x equal to 0, y will be 10. This is the nature of first equation. These are the point of first. Now, in the same way, we should find out the point of 2. Here x, here y. Okay. If we take x equal to 5, then we can get y equal to 1. If we get x equal to 4, then we can get y equal to 0. 4 right here. Y 4 minus 4 equal to 0. If we put x equal to 3, we can get y equal to minus 1. And if we put x equal to 0, then we can get y equal to 4. If we put x equal to 0, we can get y equal to 4. Clear? If we put y equal to 0, x equal to 4. Now, we should draw the graph. What will be the graph? This is line 1, this is line 2. These lines will intersect each other. There will be common. Okay. If we try to draw first line, x plus y equal to 10, then these line cut at x axis. This is the x axis, this is the y axis. If we try to find out the axis of the given equation, here we put y equal to 0 because at x axis y should be 0. Y should be 0. This point is enough. So we can draw this line. Now, second is if x equal to 4, here x maybe here x equal to 4, here x equal to 4 passes through because at y, here y equal to 0 passes through, we can get one single point. We can get one single point which satisfies both of the equation. Which satisfies both of the equation. These are the 7, 3. Clear? Now, there is the limitations of graphical method because without set of rules and regulations and practical scenario, we cannot get these point of intersection. But algebraic method will provide these solutions. Clear? Here is the point 10, 0. Here is the point 4, 0. Next questions. Let the here 5 pencils and 7 pencils together cost 50 and 7 pencil and 5 pens together cost 56. Suppose pencil taken as x and pen taken as y. Then 5 pencil, we can extract equations 5 pencil 5x, 7 pens 7y equal to 50, and 7 pencil 5 pens, cost is 46. Find out that if y equal to 0, then x will be, if we put y equal to 0, then x will be here 0, 5 1 5, 10, x will be 10. If x equal to 0, y will be 50 by 7. Okay, then we should solve these equation. If we put y equal to 0, we can get x equal to 46 by 7. And if x equal to 0, we can get, if x equal to 0, we can get y 46 by 6. Okay. If we take x equal to 3, 5 3 15, 50 minus 15, 50 minus 10, 40, 40 minus 5, 35, and we can get 35 by 7, 7 5 ja, we can get 5. Now here, if we take x equal to 3, then y will be 7 3 ja 21, 40 x 46 minus 21, it will be 6 5 4 25. Then we can get 5 5 ja. These are the common point. This is enough. If we draw lines, suppose here, okay, this is drawing. This is the point 5 by 3. Okay, this is line 1, this is line 2, this is line 1, this is line 2. Clear? Now, we should draw one more point. Okay, we can get these points. Here, first 10, 0 and y 46 by 7, 0. Clear? Now, on comparing the ratio A1 upon A2, B1 upon B2 and C1 upon C2. Find out whether the lines representing the following pairs of lines linear equation intersect at a point are parallel or coincident here in first question. A1 upon A2, A1 upon A2, B1 upon B2 and C1 upon C2. We will apply these for all. Okay. So first 5 by 7 equal to minus 4 by 6 equal to 8 by minus 9. This will be 2 to the 4, 2 3 the 6. So we can write 2, 3. Can you say that these are the equal? No, these are not equal. If these are not equal, what will be? That means it has unique solutions. It has a unique solutions because it intersect each other. Unique solution. Unique solutions. Okay. Now, in second, 9 by 18, 3 by 6, 12 by 24. What will be? 9, 9 2 ja, 3 1 ja 3, 3 2 ja 6, 12 1 ja 12. All are equal. That means coincident, overlapping. Overlapping means this is equation 1, this is equation 2. Touches every point. Touches every point. That means this is coincident. Have many solutions. Now in third part. 6 by 2 minus 3 by minus 1, 10 upon 9. 2 1 ja 2, 2 3 ja 6 and minus 3 by 1. These are the equal, but this is not equal. This is equal. If there is situation like this, that means constant term is different. If constant term is different and other are equal ratio, then we can say that these lines are parallel lines and have no solutions. Clear? Are you getting? Question third. On comparing the ratio A1 upon A2, B1 upon B2, C1 upon C2, find out whether the following pair of lines equation are consistent or inconsistent. Inconsistent means have no solution. Consistent means have solution. It may be unique or it may be many. These are the first. What will be? We should follow same rules. A1 upon A2, B1 upon B2 and C1 upon C2. Clear? Now 3 by 2 equal to 2 by minus 3. 2 by minus 3 and 5 by 7. Okay, these are not equal. If these are not equal, that means constant term is not maintained. If these are not equal, that means what will be? There is solution. There is solutions because these are intersecting each other. Unique solution. So there is solutions. We can say that this is consistent. Now, second, 2 by 4 and minus 3 by minus 6 and 8 by 9. 2 1 ja 2, 2 2 ja 4, minus 3 1 ja minus 3 2 ja. These are equal and these are different. That means this equation is parallel. If the parallel, that means have no solution. No solution means inconsistent. No solution means inconsistent. Now, third, 3 by 2 upon 9 equal to minus 5 by 3 upon minus 10, 7 by 14. 3 1 ja 3, 3 3 ja 9 and 2 3 ja 6. We can write 1 by 6. 5 2 ja 10 minus 10. Okay. 3 2 ja 6. 1 by minus 6 and say 1. Okay. Now, what will be? These are not equal. These are not equal. If these are not equal, that means we can say that if these are not equal, then we can say that it will intersect each other. If it will intersect, that means it has a unique solution. If there is solution, we can say that it is consistent. Clear? Now fourth, 5 upon minus 10 equal to minus 3 upon 6 and 11 upon 22. We can write 1 by minus 2, 1 upon minus 2, 1 upon 2. These are the same, but constant term is different. then we can say that these are the parallel lines. These are the parallel lines have no solutions. No solutions, so we can say that inconsistent. Clear? Now, fifth, 4 by 3 upon 2 and 2 by 3 and 8 by 12. 2 to the 4, then we can say 2 by 3. 2 by 3. 4 to the 8, 4 3 the 12. All are same, then coincident have many solutions. Many solutions, so consistent. Clear? Next. Question 4. Which are the following pairs of linear equations are consistent, inconsistent? If consistent, option the solutions graphically. Clear? Now we should solve it. First, we should prefer nature. For first, a1 here 1 upon 2 equal to 1 upon 2 equal to 5 upon 10. We can write 1 by 2 equal to 1 by 2, 5 to the 10, 1 by 2. All are same, that means coincident. Overlapping. If overlapping, then we can say that it is consistent, many solutions. Clear? So find out the value of here x, here y. If we take y equal to 0, x will be 5. If we take x equal to 0, y will be 5. Clear? I got the line. I can draw with these 2 points is enough to draw. Then for second equation, if we put y equal to 0, we can get x equal to 5. Just because this coincidence, so line will be same, point will be same. Clear? Now we should draw the lines. Because both lines are same. Y equal to 0, then x equal to 5, 5 comma 0 and 0 comma 5. Okay. L1 and L2. Now x minus y equal to 8, 3x minus 3y equal to 16. Second question is that x minus y equal to 8 and 3x minus 3y equal to 3x minus 3y equal to 16. 1 by 3, 1 by 3 and 8 by 16. Yeah, minus 1. 8 to the 16. Okay. Then what will be? They are equal and they are equal and they are not equal. So we constant term is different. If constant term is different, that means the equation are parallel lines. If these equations are parallel, that means have no solutions. No solutions. If there is no solutions, that means it is inconsistent. Clear? That is inconsistent. So according to the questions, we will not draw the inconsistent problem. Third, what is the third part? 2x plus y, we should check it. 2x plus y minus 6 and 4x minus 2y equal to 4. 2x plus y minus 6 equal to 0 and 4x minus 2y minus 4. 4x minus 2y minus 4 equal to 0. 2 by 4, then 2 by 4, 1 by minus 2 and minus 6 by minus 4. 1 by 2 and 1 by minus 2 and minus 9. 2 3 is 6, 2 2 is 4. Not equal to. Not equal. If give this ratio is not equal, then we can say that they intersect each other, have solution consistent. Clear? Have solution consistent. Then we should draw the lines. Okay. This is drawing. Okay. This is drawing. Now, what will be the, if we put here x, here y. If we put 0, x will be in first equation 2 3 is 6, 3. If you put x equal to 0, then y will be 6. Okay. Okay. Now, in other equation, x comma y, what will be the value? In the same way, we should put 0, y equal to 0, 4, 4, 4 1 4, 1, it is enough only. X equal to 0, we can get 2 2 4, 2. Now, if we put 2, we can get 2. Here, if we can go to this, these are the common points, so 2 comma 2, and here will be 3 comma 0, and here will be 1 comma 0. So this equation L2 and this is L1. Fourth problem, we should fourth problem. Fourth is 2x minus 2y minus 8 minus 2 and 4x minus 4y minus 5. 2x minus 2y, this is 4. 2x minus 2y minus 2 equal to 0, and 4x minus 4y minus 5 equal to 0. 2 by 4 minus 2 by minus 4 minus 2 by minus 5. 2 to 4, 1 by 2, 1 by 2, and minus 2 by 5. These are the same, but not equal to. This is not equal. So this is the parallel lines inconsistent. So we cannot find the solution. Okay. Now, what is the question of fifth? Half the parameter of rectangle garden whose length is 4 meter more than its width is 36 meter. Find the dimension of the garden. Clear? Now, length and width. So here length is whose length is 4 meter more. Length and breadth. Here length. This is x, this is y. Clear? Then given half of the parameter, (36). Half of the parameter 36. Because this is red. Clear? 36. Then x plus y will be 36. This is equation 1, and other is according questions. What will be? Length is 4. What is the length? Length is y. Length is 4 more than its y. X plus 4. Clear? This is the equation 2. This is the equation 2. Now, what will be the solution of these equation? This is L1, this is L2. Okay. Here x, y. If we put y equal to 0, we can get x equal to, if we put y equal to 0, we can get x equal to 36. If we put 0, this is 36. This is 1, and this is for equation 2. If we put y equal to 0, x equal to -4, and if we put x equal to 0, y will be 4. Okay. And if we put if we put 16, x equal to 16, then y will be 6 minus 6, 0, 3 minus 1, 20. If we put 16, if we put x equal to 16, then y will be 20. Now we should draw the clear, because here is -4 in line 2, x -4, then lines we draw from this way, and first line, this is line 2. Okay, first line is y equal to 0, that means here 0, x will be 36. So here 36 comma 0 -4 comma 0, here 16 comma 20. Clear? Find the dimension of the garden. Dimension of the garden 16 and 20 will be. This is x, this is y, this is breadth, this is the length. Given next one, given the linear equation 2x plus 3y minus 8, write another linear equation in two variables: intersecting lines, parallel lines, coincident lines. Okay. Here first equation is 2x plus 3y minus 8 equal to 0. These are the game. We want intersecting line. How? Maybe if these lines are next line prove that both lines are intersecting lines, then compare ratio. What will be? It should not equal, so we can take any number. We can here 4 and here 7. 4x 7, they never will meet each other. Here 9 equal to 0. Clear? Because a1 upon a2 not equal to, for first b1 upon b2, to follow the condition. Now parallel line, that means there will be equalness. So we can do 2x plus 3y for second minus 8 equal to 0, and 2x plus 3y minus 9 equal to 0. here a1 upon a2, b1 upon b2 not equal to c1 upon c2. And third, coincident line, that means overlapping each other. Then 2x plus 3y minus 8 equal to 0. 2 to the 4x plus 12y. 2 3 the 6y. 2 8 the 16 equal to 0. This should be, because it is coincident, so a1 upon a2 ratios, all ratios will be same. a1 upon a2, b1 upon b2 and c1 upon c2. Clear? Now next questions. Draw the graphs of the equation x minus y plus 1 equal to 0 and 3x plus 2y minus 12 equal to. Determine the coordinates of the vertical triangle from the line x-axis and set the triangular region. There is no problem. Line 1, this is line 1 and this is line 2. Find out the coordinate first. xy and here xy. Put y equal to 0, we can get x equal to 1, and x equal to 0, we can get y equal to minus 1. Here, if we put y equal to 0, we can get 3 4 ja 12. Okay. If we put x equal to 0, if we put x equal to 0, then what will we get? We will get 2 6 ja 12, 2 6 ja 12. Clear? 2 6 ja 12. Then it will be 6. Now, what will be the common point? We should search. Like, if we put x equal to 2, then y will be 2 plus 1, 3. Now here, if we put x equal to 3, x equal to 2, 2 2 ja 4, 2 3 ja 6, 6 and minus 12, minus 6 there, plus 6, 2 minus 2 3 ja 6, then 3. These are the common point. Okay. Now we should draw. Take okay. Now okay, then this is the solution. Now here is the point 2 comma 3. Here is the point 2 comma 3, and this is the point y equal to minus 1. Then y equal to minus 1 will be, and x equal to x equal to 1, then here x equal to 1. If this is line 1, and for y equal to 0 and x equal to 4, then this is line L2, here point 4 comma 0, 4 comma 0, but this line is not matching, so this now, and this we should draw. Now here is matching. Y equal to minus 1, y equal to minus 1, and x equal to 0. Okay. Now these are the coordinates and set the triangular region, so we can write. Okay. Now this is the solution of this exercise. This exercise is very longest exercise, but I believe that your dedication and your patience will be successful to gain a new energy, because if we solve more problems, we will energize and we will deep dive in the lessons. Your patience is very helpful. Thank you for watching. Please share, like and subscribe. Thank you, my dear students. If you feel any problem, please comment in comment box.